Good afternoon, everyone. We are welcome back to class for today, this afternoon. Ẹ káàsán, ẹ kú ọ̀sẹ̀ tuntun. Mo tá máa kún sọ̀rọ̀ lé lórí òun náà níbi tá a fi àgbàdá ètò rọ̀ sí ní ọ̀sẹ̀ tó kọjá. Kí ni a dẹ̀ máa sọ̀rọ̀ lé lórí lẹ́yìn òun náà ní covalent bonding under chemical combination also. Now, kí ni covalent bonding? Mo sọ in the last class that covalent bonding is a very important aspect of chemistry at which we're supposed to know. Very important. In what sense? In the sense that it's the one that will help us in having understanding of the organic chemistry. Organic chemistry 1, organic chemistry 2, and the giant molecules. The reactions, the chemical reactions that has to do with this, that has to do with that, we're supposed to, that is the one that will help us to understand it. And another topic at which is very important, that is a pre to organic chemistry, is that of hybridization. But there is no how somebody will understand organic chemistry without understanding covalent bonding. So let's go and let's see what is happening in covalent bonding. Covalent bonding. Now, covalent bonding, it is a type of a bond. In simplicity, it is a type of a bond that exists between two non-metals. I explained last time mo sọ fún wa ní ohun tí metal jẹ́ àti ohun tí non-metal jẹ́. Non-metal ìdàkejì metals ni. Ohun tí metals lè ṣe non-metals ò lè ṣe. Mo sọ ní last time pé metals can conduct electricity by kí mo dẹ̀ ṣe àkàwé wípé a fi irin kan àti ìbọ̀ iná. Electron wá pass through ẹ̀ ó dẹ̀ dé ibi tí a mú dání. Now, but a bá ń sọ nípa non-metals, example of non-metals, a ní bí paper, a ní bí wood, all those ones they are non-metals. But the element at which we have in the periodic table also, let me just use that as an example. From group 4 to group 8 in the periodic table, they are pure non-metals. From group 4, that means from carbon family to noble gases, they are non-metals. So the group 8, we may not be able to ascribe them as non-metals or non-metals or metals, and there is a reason for that. They have attained their duplet and octet structure, so they are stable elements. So let's just say from group 4 to group 7, we have the non-metals. So any elements within these groups in the periodic table, we can refer them as a what? As a non-metal. So now let's say, for example, covalent bonding, as I've said, it is a type of a bond that is existing between two non-metals. Now let's now take, for example, in hydrogen chloride, aqueous solution. Now, in this hydrogen chloride, we can actually use it for both electrovalent and covalent bonding. Now, but I want to use it because hydrogen can actually perform two functions. It can act as a metal, it can act as a non-metal. Meanwhile, hydrogen is not a metal. Hydrogen is actually a non-metal. But you can find hydrogen in two groups in the periodic table. You can find it in group 1, and likewise you can find it also in group 7 in the periodic table. Now, if hydrogen is in group 7, that tells you that it's a non-metal. Now, group 7 as a non-metal. And don't forget, it is still in that same group 7 at which we have chlorine. We have fluorine, we have chlorine, we have bromine, we have iodine, and we have aspartame. Now all those ones, we have them to be in group 7 in the periodic table. Now, let's now assume I have hydrogen to be functioning as group 7 in the periodic, to be part of the group 7 element. That means you wanted to gain electron. It's not ready to lose electron now. It's ready to gain electron. And when it is gaining electron like that, that means it will now, the number of electrons at which it will have now, it will be 2 electrons like that. So then chlorine also needed to do what? To gain 1 electron. So when it gains the 1 electron, it becomes 18. From 17 to 18. I believe we understand that. Now, let's now go into it. Now, sharing of electron equal. Now, when we are now talking about covalent bonding is the sharing of equal amount of electron for the two parties or the two non-metals to share. Now what am I saying? Kí ni mò ń sọ? Ohun tí mò ń sọ náà ni wípé non-metal méjèèjì yẹn tí wọ́n fẹ́ bond papọ̀, wọ́n gbọ́dọ̀ donate iye electron kankan náà, iye number of electron kankan náà ni àwọn méjèèjì gbọ́dọ̀ donate. Tí wọ́n bá ti wá donate iye number of electron kankan náà yẹn, wọ́n jọ wá share rẹ̀. Now ẹ jẹ́ ká wò bí ó ti ṣe lọ. Na hydrogen, ó ní hydrogen atom, ó ní electron kan ní átámù ṣẹlẹ̀. Chlorine, òun ní electron méje ní átámù ṣẹlẹ̀. This is chlorine atom. So this is 287, the KLM shell. So this is for hydrogen, this is chlorine atom. Now, chlorine is ready to bond with this hydrogen atom. And when they wanted to bond like that, then it becomes something like this. So we have hydrogen to be here, and we have the valence shell rather, of chlorine atom to be there. Then we have this, we have this. So this is 2, 8. Then we have, now electron kan péré òun ni hydrogen ní. Now eléyìí dẹ̀ ní electron méje ní shell tó gbẹ̀yìn tá a máa ń pè ní valence shell. Now mo jọ wá donate ẹyọ kọ̀ọ̀kan equal amount of electron. So hydrogen máa donate títí tiẹ̀, chlorine náà máa donate títí tiẹ̀. So tí wọ́n bá ti wá donate ẹ̀ bẹ́ẹ̀ yẹn, ó máa wà ní irú bíbá. Check the shell méjèèjì, the atomic shell of the two atoms. The atomic shell of the two atoms ó fi ẹ̀gbẹ́ ẹ̀gbẹ́ báyìí. Now ibi tí electron tá méjèèjì wá donate sí yẹn tí wọ́n wà ní, ó là ń pè ní electron density. So this is our electron density. Electron density. So it's a region or space where the donated electron between two species at which they are bonding together. Bó ti ṣe ṣẹlẹ̀. Now this is the type of bond tá à ń pè ní ordinary covalent bonding. Ṣẹ́gun mo sọ ní ọjọ́ tí a bẹ̀rẹ̀ topic yìí wípé covalent bonding ó pín sí ọ̀nà méjì. A ní tó jẹ́ ordinary covalent bonding, a dẹ̀ tún ní ìkan tó tún jẹ́ coordinate or dative covalent bonding. Dative covalent bonding. Now, so èyí tí mo ṣàlàyé nísìn òun ni à ń pè ní ordinary covalent bonding. So ní tó ti wá ṣẹlẹ̀ nígbà àti ní hydrogen to be -1. So electron méjèèjì yìí àwọn méjèèjì ni wọ́n jọ ń share. So a lè ka méjèèjì yìí to be 1, 2 fún hydrogen, ó ti attain duplex structure nìyẹn. A lè ka fún chlorine yìí náà, ó ti wá di 1, 2, 3, 4, 5, 6, 7, 8. Ṣé ìgbà tí mo sọ yẹn ṣó yé wa ṣá? 1, 2, 3, 4, 5, 6, 7, 8. So 8 fún chlorine, 2 fún hydrogen nípa donation of equal amount of electron for both of them to share. So this is hydrogen chloride. This is hydrogen chloride. Now kí tó wá ṣe hydrogen chloride nìkan náà láti rí. There are some atoms kan tí mo sọ fún wa rí nígbà tí a bẹ̀rẹ̀ topic yìí wípé there are some atoms at which we call diatomic. And mo dẹ̀ sọ pé a ní N2 to be an example, a ní Cl2, a ní O2 like that, a ní F2, Br2, R2. They are diatomic in the sense pé wọn ò lè dá dúró fúnra wọn. Like some other atoms at which we have them to be monoatomic, the likes of almost all the metals. We have sodium atom, we have aluminium, we have magnesium, we have calcium, even we have lithium. All those ones, they are monoatomic. But when it has to do with diatomic like that, the type of bond that is existing in a diatomic is ordinary covalent bonding. So this is what we now call, so another name at which you can call a diatomic is a molecule. So this is a molecule of nitrogen, this is a molecule of fluorine, this is a molecule of oxygen, this is a molecule of fluorine, a molecule of bromine, a molecule of iodine. So in that one sọ níbẹ̀ ni pé atoms méjì ló parapapọ̀ tí wọ́n di molecule kan. Bí wọ́n ṣe parapọ̀ pọ̀ yẹn náà kí wọ́n ṣe pé wọ́n kàn parapọ̀ bẹ́ẹ̀, nǹkan kan ló so wọ́n pọ̀. Something binded them together, in which we call ordinary covalent bonding. Ordinary covalent bonding. Òun ló so wọ́n papọ̀. Ẹ jẹ́ kí n ṣàlàyé ẹyọ kan nínú rẹ̀ fún wa. Now let's look at chlorine molecule. Now chlorine molecule bó ti ṣe wà tẹ́lẹ̀, this is chlorine molecule, Cl2. Only 7 electrons in the atom shell. 7 electrons. Ẹyọ kan wà báyìí. Chlorine eléyìí náà, òun náà ní, okay, ẹ jẹ́ kí n lò báyìí. Òun náà ní ẹyọ kan. Now, àwọn méjèèjì wọ́n wá máa donate equal amount of electron for both of them to share. So yóò máa ní báyìí. So wọ́n jọ donate ẹyọ kọ̀ọ̀kan báyìí. So this is 6, 6. So this is the outermost shell of chlorine ni mo ń draw yẹn, the valence shell fún chlorine kọ̀ọ̀kan o ni mo yà yìí. That means 2, 8 ó ṣì wà nínú fáwọn méjèèjì. So 2, 8. So 2, 8 ó ṣì wà nínú. So this is the formation of chlorine molecule. Now tá bá wá fẹ́ kọ́ in the molecular formula o ní yìí. Cl2. Cl2 yìí ó náà tún túmọ̀ sí pé Cl. That means nǹkan kan bí tó dàbí dash táwọn yìí is not a dash. Though you can call it a dash, but it is a bond. And the type of bond at which it is a single covalent bond. Single covalent bond. Olóò exist láàrin àwọn méjì. That means electron méjèèjì táwọn méjèèjì donate yẹn, ẹyọkan bí ẹyọkan níbí báyìí. So that means in a bond, in a single bond like this, we have a pair of electrons. So tá bá ní bond kan yìí báyìí, this is a single covalent bond. Electron méjì ló wà ńbẹ̀. Electron méjì ló wà ńbẹ̀. So bá ṣe ní fún nitrogen náà nìyẹn N2. We have it to be, so if we have N2 like this, we have it to be Nn. So this one has unbonded electron. Ní nitrogen, check it. Nitrogen, what's the atomic number? 7. That is 2, 5. So méjì ni òun. Now bó ṣe wá wà yìí, òun gbọ́dọ̀ tó bá fẹ́ bond pẹ̀lú nitrogen ẹgbẹ́ to be a molecule like that. Ẹ máa wo, tó bá donate ẹyọ kọ̀ọ̀kan ṣe àpò máa kú mẹ́rin mẹ́rin. Wọ́n ti donate ẹyọ kọ̀ọ̀kan máa kú mẹ́rin mẹ́rin. Now ó máa jẹ́ méjì. So 2, 4 plus the 2. Táwọn méjèèjì ti jọ donate yẹn 1, 1 tó ti jẹ́ 2 tó wà níbi electron density tí wọ́n ti jọ donate yẹn. That means kò tí ì pé, that is 6. Ó dẹ̀ lọ sí 8. Ṣé ẹ wọn náà sáyẹn ìgbà tí mo jọ àìsàn? Ó dẹ̀ lọ sí 8. So for it láti wá lè pè bẹ́yẹn, okay, tó bá yẹ kó donate méjì méjì nǹkan, tó bá donate méjì méjì, ṣé ẹ ti rí bí mo ṣe mú? Tó bá donate méjì méjì, tó bá donate méjì méjì, okay, tó bá donate méjì méjì, yeah. Now mo fẹ́ ṣàlàyé bí nitrogen yìí bí wọ́n ṣe bond papọ̀. Nitrogen ò ní gba single covalent bond. Táwọn méjèèjì fi máa jọ bond mọ́ra wọn. Ẹ jẹ́ ká wò. Nitrogen is 2, 5. 2, 5. Another nitrogen meet on it. 2, 5. So àwọn méjèèjì yìí fẹ́ bond papọ̀ láti lè di molecule which is N2. Láti lè di molecule which is N2. Now tí wọ́n bá donate ẹyọ kọ̀ọ̀kan, tí wọ́n bá jọ donate ẹyọ kọ̀ọ̀kan mẹ́rin tí wọ́n papọ̀ báyìí, tí wọ́n jọ donate ẹyọ kọ̀ọ̀kan, that means wọ́n máa jẹ́ 1, 2, 3, 4, 5, 6 fún eléyìí. Fún eléyìí náà 1, 2, 3, 4, 5, 6. That means kò tí ì pé octet structure tí wọ́n fi máa balance papọ̀. because the octet structure is the attainment of the stability for every atoms